Alright guys, so the trinomials that we've looked at so far all had an a value that was equal to 1, and we were able to just factor them using what multiplies to be c and adds to be our b value. Today we're going to look at the ones where you have a trinomial and your a value is greater than 1, but you can't take out that as a GCF to get it to be 1. So let's look at this one. 3x squared plus 8x plus 4. 3, 8, and 4 do not all have a GCF or anything in common. So instead of being able to factor that out, I have to use it in my answer. Those of you that had Miss Miller for intro last year have probably seen this method before. You may have also seen the box method depending on who your Algebra 1 teacher was. So we're going to use the rainbow method to solve this. Okay, that's going to involve us multiplying our a times our c values. So this is your a, this is your c. We're going to multiply those two things together. So you have x squared plus 8x plus 12. Now we have an a value that's equal to 1, and it's going to work exactly the same way as what we were doing the past couple of days. What multiplies to be 12 and adds to be 8. So go through your factors of 12. 1 and 12, 2 and 6, 3 and 4. 2 and 6 are going to work here. This is positive, so both of your signs are going to be the same, and they're both going to be positive. So x plus, 2 goes here, 6 goes here. Now, the only difference is that because you multiplied by the a value in the beginning, we multiplied by 3, we have to divide out by 3. So we're going to divide each of these terms by 3. Reduce your fractions. So x plus 6 over 3, 6 divided by 3 is 2. So this just becomes x plus 2. Here, 2/3 is in simplest form. If you have a fraction that does not reduce, you just bring your denominator up to the front, and it becomes your coefficient of x. So this factor is 3x plus 2. Now again, we can be able to check these by FOILing. So we have 3x times x, which gives us 3x squared. We have our outside terms, so 3x times 2 is 6x. Then we have 2x. Then we have 4. 3x squared plus 8x plus 4 is what we should end up with. So our final factors are these two right here, the 3x plus 2 and the x plus 2. Looking at this next one, check if it has a GCF. 2, negative 11, 7. Nothing in common. Try to multiply it. Try to rainbow. So x squared minus 11x plus 14. Are there any factors that will multiply to be 14 and add to be negative 11? Well, if we look at this, we have 1 and 14 that multiply to be 14, and 2 and 7. Those are our only two options. Neither of those are going to add to give me a negative 11, which means that this one is not factorable. When they're not factorable, they're also called prime. And we're going to look at later how we can solve these when they become equations and they're not factorable. But for right now, this will be your final answer. Check out this next one. Remember to always check for a GCF first. So in this case, you do have a GCF. Factor out that 2. You're left with x squared plus 7x plus 12. Now we've got this trinomial that has an a value of 1, which we're used to looking at already. So it's what multiplies to be 12 and adds to be 7. Both of our signs are going to be the same. They're both going to be positive. So x plus and x plus, going through the factors of 12, 1 and 12, 2 and 6, 3 and 4. The two that are going to add to be 7 are 3 and 4. So x plus 3, x plus 4. Don't forget about this 2 from the beginning as part of your final answer. So 2 times x plus 3 times x plus 4 is your final answer. look at this next one, we don't have a GCF again, so we want to rainbow it. We want to multiply 2 times 20. So x squared plus 13x plus 40. Now we're looking for factors of 40 that add to be 13. Again, if you're not sure, go through all of them. 8 and 5 are going to add to give me 13. They're both going to be plus, so I have x plus 8 times x plus 5. Then I need to divide by 2 because I multiplied by it in the beginning. Reduce these to their simplest form, so x plus 4. This one doesn't reduce, so it's just 2x plus 5. We bring that 2 up to the front. Again, you should be able to FOIL these back together and check. So if you were to check up here, x plus 8 times x plus 5, that's not going to give you what you originally started with. So you need to remember to divide out. On this next one, 6, 15, negative 9. There is a GCF here. We want to check for that first. Unfortunately, the largest number that we can factor out this time is a 3. So we still have 2x squared, which should be plus 5x, and minus 3. A is still greater than 1, so we have to rainbow. Leave your 3 on the outside. X squared plus 5x minus 6. What multiplies to be a negative 6 and adds to be 5? Here's where these can get a little tricky because you've got 1 and 6 or 2 and 3 as your factors. Either way, these can add to be 5. It's a matter of your signs. In this case, your signs have to be different because they multiply to be a negative number. So if I have a negative 2 and a positive 3, or a negative 3 and a positive 2, that's not going to give me my positive 5. So I've got to use this first one, 1 and 6. The larger factor goes with the first sign, remember? So in this case, we have 3, and then we have x plus 6 and x minus 1. Don't forget to divide. So divide by 2. Divide by 2. You have 3 times x plus 3, and then 2x minus 1. Looking at this next one, you have 4x squared minus 4x minus 35. No GCF here, and we have an a value that's greater than 1, so we want to multiply. X squared minus 4x, and when we multiply negative 35 times 4, we get a negative 140. So this one might take you a little bit longer to find the factors, since they actually have to multiply to be a pretty large number. But knowing that your factors have to be different signs and must add to be a negative 4, we should get that our factors are x plus 10 and x minus 14. Divide by what you multiplied by. So in this case it was 4. Here, 10 over 4 is going to reduce to 5 over 2. So go ahead and reduce that fraction. But notice that it's still not a whole number, so we still have to bring our 2x out front. So 2x plus 5 is this factor. And then for this next one, it reduces, and we get x minus 7 halves. That one's in simplest form, so we bring our 2 to the front, so 2x minus 7. When you multiply these back together, again, you've got 2x and 2x is 4x squared minus 14x plus 10x minus 35. So 4x squared minus 4x minus 35 is what we should end up with. Even if you remember up here to divide by 4, but you don't reduce your fractions, look at what happens. If I tried to do this, and say that I had 4x plus 10 and 4x minus 14, and then you go to FOIL these back together, with your first terms, you already have 16x squared. That's not what I started with up here. It's a 4x squared. So I know that this is not correct. If you do it this way, they all have a GCF that you're going to have to factor out. So taking out that 2 results in 2x plus 5, and then taking out the 2 from here results in 2x minus 7. So we want to make sure that we reduce everything to its simplest form before solving. Our last example here, we multiply, since it doesn't have a GCF, and we get x squared plus 7x minus 120. Factors of 120 that are going to add to be 7. Again, might take you a little bit longer to find these. Opposite signs because this one is negative. So x plus something and x minus something. In this case, 15 and 8 are the two numbers that will multiply to be a negative 120 and also add to give you 7. Divide by 6. Again, we want to reduce our fractions. 15 over 6 reduces to 5 over 2. And 8 over 6 reduces to 4 over 3. Bring your 2 out front, so it's 2x plus 5. Bring your 3 out front, so it's 3x minus 4.